What if I told you that you can run a self-improving AI agent on a small Raspberry Pi inside your own home without exposing it to the public internet? Not on a cloud VM, not on some publicly accessible server, not with port forwarding on your router, but with your own hardware properly secured. Because the reality is simple. The moment you expose a device to the internet, it starts getting scanned. Bots try password, automated scripts look for weak SSH setups. Now imagine a device that is running an AI agent that can execute shell commands and modify its own code. That's powerful. And power without security is just a mistake waiting to happen. So in this video, we are going to do this properly. I took an old Raspberry Pi 4 and then step by step converted it to a hardened Linux machine with SSH key based authentication, no password login, no public ports exposed, a private encrypted Tailscale network, a fully isolated system user, and a self improving AI agent working 24/7 as a background service. And I won't just show you commands, I will explain why we are running them. Because if you are deploying an autonomous AI system, you should understand the system it runs on. So let's start. Now, one thing to note here is that you should have a Raspberry Pi 4 with a 64-bit architecture, and you should have SSH enabled during the OS installed. The first step is to SSH into the Raspberry Pi. You can use the command ifconfig to find the IP address of your Raspberry Pi and then SSH into it. Now I had reinstalled my Raspberry Pi OS, so it is detecting the old SSH. To fix that, I will use SSH keygen command, and with that I will be able to generate new SSH keys, and I have to SSH into my Raspberry Pi. After that, you have to run the two commands, that is sudo apt update and sudo apt upgrade, to update the dependencies. Once that is done, the next step is to install Node into our Raspberry Pi. Now the process is very simple. Go to the Node.js website, select the Linux operating system, and copy and paste the commands given here. This will install Node.js on your Raspberry Pi using NVM. Now, once Node.js is installed, the first step is to secure our remote access, because if the SSH is weak, everything else is pointless. So we will run this command ssh keygen -t ed25519 -a100. ed25519 is a modern elliptic curve crypto, and -a100 strengthens the passphrase protection. So what we are doing here is we are generating asymmetric keys for accessing our servers. We don't want password-based authentication for our server, because if we do that, someone could brute force the password into the server. So once we run this command, you have to give a passphrase, confirm it, and the asymmetric keys will be generated. Now the next step is to copy the public key into our Raspberry Pi server. So the private key stays into our laptop and the public key stays into our Raspberry Pi. So onto our Raspberry Pi, we will make a directory named SSH, and then we will run a command chmod 700 with that directory. Now, once we do chmod 700, only owner can access that directory. Now let's open the authorized keys file in the SSH directory using the nano command, and we have to enter our public key. You can do Ctrl O to write out from the nano editor and press enter to save the file. After that, press Ctrl X to exit from the nano editor. Now we'll run the command chmod 600 and the name of the directory. This means that only owner can read or write that file. So basically, SSH will refuse all insecure permissions. Once that is done, we can close our SSH connection, then retry the login through SSH. And we should not be prompted for any password. We just have to enter the passphrase and we should be able to log in into our server. After that, the next step is to deactivate the password authentication. So we'll enter the command sudo nano /etc /ssh /sshd underscore config. So here, just change the password authentication text to no and remove the hash to uncomment that line. We will also remove the root login access and we will write challenge response authentication no so that we can disable any alternate authentication mechanism that we are not using. If we don't need it, we remove it. So basically, we are removing everything that we don't require explicitly. Next, we have to run the command sudo systemctl restart ssh. Then we will try to log in again using the ssh command and we should be able to log in easily without any password. The next step is to install the firewall. So we will use UFW or uncomplicated firewall into a Raspberry Pi server. So for that, we run the command sudo apt install UFW and this will install the uncomplicated firewall into our Raspberry Pi server. The next step is that we will deny all incoming connections into our server and we will allow only outgoing connections from our server. Once that is done, the only incoming connection which we want to allow is the SSH. So for that, we can run sudo UFW allow SSH and after that, we will enable the firewall using sudo UFW enable. And you will see a message that firewall is active and enabled on system startup. So at this stage, my server has no password authentication, no root login, only SSH is exposed. Firewall is blocking everything else. We have verified access path and clean admin user. At this point, even if someone scans my public IP address, they cannot brute force my system. The only way in is possession of my private cryptographic key, which is securely saved on my laptop. So until and unless someone has the physical access of my system, they cannot get into my server. But we are not done here. SSH is still technically exposed to the network. So next, we will remove the public exposure entirely using Tailscale and will create a private encrypted network that will make our Raspberry Pi server invisible to the outside internet. Now, Tailscale is a VPN service which is absolutely free. I think it's free for 3 devices. And in some tutorials, you might see that they tell you to do a port forwarding onto your router. Now that is something which I don't want to do because port forwarding exposes your device to the entire internet. Instead, I'm using a zero trust encrypted mesh network. So basically, we are creating a private tunnel between our two devices, my laptop and my Raspberry Pi server, where I'm going to install OpenClaw, and only the devices on my Tailscale network will be able to access my server. So that makes my server really secure and nobody else can get access to it until and unless they are on my Tailscale network. Now to download Tailscale, go to the downloads page and choose the Linux operating system. Just copy the given command and paste it in the Raspberry Pi session. Let the process complete and you will have Tailscale installed on your Raspberry Pi. Next, enter the command sudo tailscale up and add a --SSH flag to allow SSH into the Tailscale network. You will be prompted to authenticate through your Tailnet account. So just authenticate it or create a new account and you will be good to go. Next, you have to download Tailscale on your laptop or the computer on which you are working as well, so that you can use Tailnet on both the devices. Now, since I have already installed Tailscale on my laptop, so I'm not going to do it, but the installation is pretty simple. Once you do it, you will see both the devices into your Tailscale account. Next, you have to copy the Tailscale IP address, which is given here, and try to SSH through that account. If you did everything correctly, you should be able to log in into the Raspberry Pi through the IP address provided by Tailscale. Now, this is not the public IP address which is exposed to the internet. This is the IP address which is inside an encrypted VPN and which only you can access through a device which is on your tailnet. Since we have installed Tailscale on our laptop and added it to our tailnet, we can access it through our own laptop. Nobody else will ever be able to see it or find it. Once we have confirmed that we are able to log in into our Raspberry Pi server, we can now close the TCP port through the firewall. So we'll run the command sudo ufw deny SSH. And with this, we have closed all incoming ports to our Raspberry Pi server. Now let's try to SSH into our Raspberry Pi through the original IP address of the Raspberry Pi. And you can see that it will fail because this is not accessible as I explained earlier. So the only way you can log in into your Raspberry Pi server is through the Tailscale IP address. The next step is to add a system user for OpenClaw. I don't want my OpenClaw instance to stay on the root instance because it will have access to all my root files and it can change or modify those files which I don't want. So to create a complete isolation, I will create a different system account named OpenClaw and give it its own working directory. And the OpenClaw instance will reside only in that directory and it will have only the permission to edit and modify files into those directory. That's why I will keep my main space and the OpenClaw space isolated on the same machine. Once we have created the user using the sudo add user command, then we can do id OpenClaw to check whether the OpenClaw has the sudo access or not. Since we can see that the id is less than 1000, that guarantees that this account does not have sudo access. After that, we will do sudo chown r and we will give the username and the directory. Basically, what this does is that it gives the permission of OpenClaw directory to the OpenClaw user. And the flag R does it recursively for all the files. Then we run the command sudo chmod 750 and the OpenClaw directory to give the read, write and execute access to OpenClaw. Next, we will restrict the access to our home directory through chmod 700 and /home/rpi. Once that is done, we will enter the command sudo-u openclaw-h bash to log in as the OpenClaw user. You can check that with the whoami command, so that prints OpenClaw. Next, we can print the working directory through the pwd command and you can see that right now the working directory is the home directory. So we will change that by cd/opt/openclaw and that will change our working directory to the OpenClaw directory which we have created. And that completes the hardening of our system. And now we are going to the most interesting part which you have been waiting for till now, the installation of OpenClaw. But before we move further, let's take a moment to assess the security status of our machine. Right now, we have secured this Raspberry Pi from external threats. First, we are using asymmetric SSH key authentication. That means no password login, no remote password brute forcing, no root login, and no alternative remote access methods. Only the machines that possess our private SSH key can log in. Secondly, there are no open ports exposed to the public internet. The firewall denies all inbound connections. The only way this machine can be accessed remotely is if someone inside my Tailscale network and and even those devices have to be manually approved into that network. So from an external attack surface perspective, the machine is completely sealed. Now let's talk about internal containment. We created a dedicated system user for OpenClaw with very limited permissions. That means OpenClaw does not run as a root, it does not have sudo access, it cannot modify system files, it cannot access other users' home directory. It can only operate inside its own directory. So even if something goes wrong, the damage is fully contained. And this is called least privilege architecture. Now, yes, security is inversely proportional to convenience. So, when you build a system this secure, you must manually configure certain things, but that is intentional. So, I don't want OpenClaw deleting important files, modifying system configs, or accidentally exposing something to the internet. Now, coming to the OpenClaw installation. During the installation, I encountered multiple issues and I intentionally left few of those parts unedited because when you will install on your instance, you will likely face similar issues. And understanding how to fix them is very important. Now let's install the OpenClaw inside the OpenClaw user. We go to the OpenClaw website, select Linux, copy the install command, and paste it in the OpenClaw user terminal. Before doing that, make sure you are switched to the OpenClaw user and you are inside the slash opt slash OpenClaw directory. Now, when we run the installer, we see that the Node.js is not installed. Now, even though we had installed Node system-wide, that was under another user. Because this is an isolated system user, it cannot access Node installed elsewhere. So we will have to install the Node.js again. And in this time, we will use NVM, but inside our OpenClaw user. So when we install the node, it will install locally under slash opt slash openclaw slash dot nvm. Once the node is installed, we will retry installing OpenClaw. So after a while, you can see the OpenClaw now is installed successfully. Right now, we will just skip through the proper configuration. We will just select placeholder values because we will reinstall it properly using the daemon. Now we need two important things for doing the OpenClaw setup. First is a paid ChatGPT plan with Codex access or an OpenAI or Anthropic or any other LLM provider API key. And the second thing is the Telegram account because we will be accessing the OpenClaw user through Telegram, which is the most easiest and the recommended way to do it. And in this setup, I'll be using Codex through my ChatGPT plan. I'm on a ChatGPT Go plan, which is around $4 in India. After the installation, we need to fix something important. Because we installed Node using NVM, we must ensure that the node loads correctly for the OpenClaw user. So we will have to edit the .bashrc file and .profile file inside the /opt /OpenClaw directory because otherwise the node will not load automatically in every shell and you will not be able to access the OpenClaw. Use the nano editor and add these lines into the bashrc and the profile files. After that, we will switch properly into the user using sudo -u openclaw-h bash-l command. Now, the -l here is critical because it loads a login shell, which ensures that the .profile and .bashrc are executed. Now we'll verify that our system can see node, check the node version, and let's check the OpenClaw version. If both are working, then the environment is correct. Now let's run the OpenClaw install daemon again. So for that, we will use the command OpenClaw onboard --install -daemon. Now this time we will do the onboarding properly. So let's run the command. Yes, I understand that this is powerful. We will select the onboarding mode as manual. We will reset the config handling, reset scope to full reset. So I want to set the local gateway on this machine. Then we will keep the workspace directory as it is. And then we will choose the model provider as OpenAI Codex. It will give us a OAuth URL. We have to copy the URL and paste it in a browser. Now log in through your credentials, click on continue, and you will be redirected to a link. Now in this link, copy the portion after code and till the ampersand sign and paste it in the redirect URL. Now keep the default model, keep the gateway port as it is. The gateway bind should be loopback, gateway auth should be token. We don't want Tailscale exposure. And then we will configure the chat channel. So yes, I want to configure the chat channel. And now we will set up our Telegram account. Now let's come to the Telegram setup. Open Telegram, create an account on it, and search for botfather. Start a new chat and type /new bot. Give your bot a name and a unique username. The botfather will give you a token. Paste that token into OpenClaw. Once we have pasted the token, click on finish. Then we want to configure the DM access policies. So click on yes. We will not be configuring the skills right now. And we also don't want to enable the hooks. Now we'll see the message systemd user services are unavailable. So we have to work on this. Now at this point, I tried to chat with my bot, but it was not responding. Why? Because the gateway is not running. To run the gateway, we can do OpenClaw gateway. Now the gateway starts. Now again, we will try to send a message to our bot through Telegram, and we should get a message saying that access is not configured. So just copy the pairing code and then run the command OpenClaw pairing approve Telegram and paste the code here. And now the Telegram will work perfectly fine. So once the Telegram is working, we can start the gateway in one tab using OpenClaw Gateway and start the TUI or the terminal user interface in another tab. But that is not ideal. We should just be running the OpenClaw TUI command and it should automatically start the gateway. The another issue which I found was due to the way we have set up the OpenClaw user, the OpenClaw user cannot write files. As a result, it cannot do git commits. But the cool part is that the OpenClaw bot is running and you can ask all these queries directly from the bot and it will give you a solution. So let's initialize our OpenClaw agent and then we will solve these issues. Now we created the OpenClaw as a Linux system user, and Linux system user are configured as no login shell because that prevents shell execution. Since OpenClaw modifies its own code, that is the main feature of OpenClaw, that it can self-improve itself over time based on our interactions. So we do want Git enabled, but without giving root privileges. So we have to change the shell to /bin/bash. This allows shell execution but does not grant sudo privileges. Now, right now we are using the gateway in another terminal and running the TUI separately. That is not how it should work. When we should run the OpenClaw TUI, it should automatically start the gateway. For that, we have to create a systemd service file. And you can see that the OpenClaw service does not exist. So we have to create /etc/systemd/system openclaw.service. This file tells Linux which user to run as, where to run from, how to load NVM, and how to restart automatically. After configuring these files, we will run sudo systemctl daemon reload, sudo systemctl enable OpenClaw, then sudo systemctl start OpenClaw. Now the OpenClaw will run perfectly in the background. It will automatically start on boot, and even if the SSH is disconnected, we will be able to use our OpenClaw port. So now you can see that the Git is working. However, the commit has failed because the Git requires identity setup. So we have to configure the username and the email, and you can set any name and any email as the Git identity. And after setting things up, OpenClaw can now safely modify and commits its own code, and everything is working perfectly as expected. We want to do is to access the gateway dashboard or the control panel of our OpenClaw. The gateway binds to 127.0.0.1, which means it is accessible only inside the server. So we have to create a SSH tunnel. For that, we will use the command ssh-n-l, and then we have to forward our laptop's port 18789 to the Raspberry Pi's loopback port. So we'll say 18789 colon, after that the gateway port of the Raspberry Pi, and then we have to give the IP address, the Tailscale IP address of our Raspberry Pi. Now, if we open the localhost 18789, it will work perfectly. However, you can see that we have got an error saying that we do not have the gateway token. So again, we can just ask it from the bot, and it will give us a command to get the gateway token. Let's run this command, and we will get a gateway token. Copy this token and paste it in here and click on connect, and now everything should be working perfectly fine. Our gateway dashboard is connected and our OpenClaw instance is now running perfectly. So one thing I would like to tell you here is the skills. You can see a lot of skills here, which are the built-in skills, which are not enabled by default. We will enable them subsequently in another video because this is the setup video of OpenClaw. So skills are basically which gives our bot real world abilities. So we will explore that in the next video. Now, before ending, let's talk about usage monitoring. If you're using the API keys, you can monitor that from OpenAI or Anthropic API dashboard. Now, if you are using Codex via ChatGPT plan, you can go on to chatgpt.com/codex/settings/usage, and you can also monitor the usage directly inside the OpenClaw dashboard. It gives you a detailed usage stacks. So it is very important to track the usage. Like for example, if you're on the Codex plan, then it is probably fine because once you have exceeded your usage limit, your bot will stop working. But if you're using it through the API, you need to track the usage and monitor the tokens. So that completes our ultra secure OpenClaw setup. We have now hardened SSH. We don't have any public ports, Tailscale only remote access, isolated service user, NVM based runtime, systemd daemon, Git enabled self-modifying agent, Telegram integration, and a secure dashboard access. In the next video, we will explore skills and turn this into a real autonomous system. Till then, keep experimenting with your bot. Take care. See you in the next video. Bye bye.